That's fine. Okay, so I'm going to draw the graph to the best of my abilities. So when we are finding the area between two curves, for example, if I have these two parabolas, she's not pretty, but she works. We start by finding the area under the top one, so we're going to call that F.
Where's our bound?
From where they intersect. So here we're just going to call that A and B. So the first thing we do is we find the area under F of X, and then we subtract from it, I'm going to draw again, the area under my bottom curve on that same interval, so that would be this part right here, and we're going to call that G. And then that gives us the area between them, which is the integral from A to B of F minus G. So the integral, or the answer of the area between two curves, is the integral from intersection to intersection of the top minus the bottom. That's a fancy way of writing that. It looks much better in my notes.
We have the test.
You will be having something soon.
Robert, what is that? No, it can't
Chances
go
are no,
further.
because volumes is going to take us more than,
It's great if you're not already have a B.
so that may help you.
No, it won't.
We'll see. Okay, so what we're going to do today is just 5 examples that practice area between two curves. We might not do all 5 of them if you pick up on it really quickly, or we might do all 5. Who knows?
I'm ready for this.
It is. It really doesn't
I
get
think you said
too complicated.
Well, she said 4.
I said 4, and then I forgot I had a free-handed one on the back.
and then we have 5 on
There are 5 on homework. So we're just going to start with an example. This is to find the area of the region bounded y equals x squared plus 2, y equals negative x equals 0, and x equals 1. I'm going to go ahead and draw a graph of what this looks like. You don't have to draw a graph to necessarily solve this, but it is helpful. Where did I get what? I drew it from those functions. So my red function is the x squared plus 2. My green function is y equals negative x. The interval it gave me was from 0 to 1. So that's what my blue is. And then that blue shaded section is the area I'm trying to find. So this is my function f, this is my function g, and these are my a and b, or my integration bounds. It will not always give you the integration bounds, but some of them will. So then the hardest part here is I have to check to see if my functions intersect on the interval I was given. If they do, I might have more than one integral that I have to calculate. And then I have to determine which function is on top for each of those sections. So here we have no intersection, so we're looking at just one integral. Which function is on top in this integral? It is f, because it's the parabola, which is y equals x squared plus 2. So I'm going to integrate from 0 to 1, because those are my integration bounds, of my top function, which is x squared plus 2, minus my bottom function, which is negative x.
Wait, so y squared, the y1, that is f.
This is f minus g.
Okay. So like
It gave you both equations, yeah. And then I would either plug this into my calculator, which you know how to do, or I'm gonna do it the old school way where we anti-derive them, just so you can see how it works out. Of course, I've heard a lot of calculators come out. So this would be the same as the integral from 0 to 1 of, I put this together, and I get x squared plus x plus 2 dx. I can then anti-differentiate this, and it becomes x cubed over 3 plus x squared over 2 plus 2x, solved at 0 and 1. And you should get 17 over 16. Sorry, 17 over 16. What'd you get? No, you should get 1 point something.
I got 2.833.
Yeah, that's
It's 17 over 6. No, 17 over 6 is 1.06.
17 over 6 or 17 over 16.
17 over
That's
16.
what I meant to say. That's 1 point.
2, 3, 5,
No, we all got
2. No, I just can't do math apparently. Because that would be
Can we use the decimal?
2 over 6. Yes, you can. 3 over 6, 5 over 6, 2, and 5, 6, 12, 17. Oh, it'd be 17 over 6. That's what it was. I just wrote it wrong on my notes. Which is what decimal? 2 point.
2.83.
I will fix that on my notes.
Oh, sweet note.
So how do we know what functions to subtract from what function?
The one on top is the one that we just have normal, and we subtract from it the one on the bottom.
Put those on the.
Well, I just graphed them, like put them in my function and graph them, or you could pick a point on the interval, plug that x value into both, and just see which one gives you the bigger number as an answer.
But they couldn't correct from.
Right, so we will look at that one.
Do we have to flip? We have to make the integrals, like, separate them into different intervals? And each one
Based off the intersection, yeah, but I'll show you that one. Okay, so if it gives you the bounds like this, chances are it's not intersecting, but you can definitely graph both of these functions. You could just put the x squared plus 2 in for y1, you could put the negative x in for y2, and you could adjust your domain on your window, and then you could just see if it intersects or not. If it doesn't, you don't have to worry about separate integrals. If it does give you bounds though, I'm gonna show you how to find what your bounds would be and how to find where they intersect. So we are going to do one where it actually didn't give me any bounds as our next example.
He said something about that. Oh.
So on this one, it just asked me to find the area of the region bounded by f of x and g of x given these two functions. This means I'm looking for the enclosed space created by intersection points. So the first thing I need to do is I need to find intersection points. I'm also going to show you what the graph of this one looks like just so you can kind of see what's happening. But you don't have to have a graph for this. It is helpful. So I'm going to make S green just so we can see. And then I'm going to make G red. So if I had graphed this and I saw this graph, I would clearly see that we have two intersections here. I don't have any x values though to figure out what they are. So what's the easiest way to find the intersection of two functions?
System.
Even easier than that. I just set them equal to each other. And I solve for the x values that make them equal, because that would be an intersection. So I take 2 minus x squared and I set it equal to x. And then I solve for x. Clearly this is going to be a quadratic, so I'm going to move everything from the left over to the right so it's positive. And I get 0 equals x squared plus x minus 2. You can do the quadratic formula or you can factor it. I'm going to tell you that it factors into x plus 2, x minus 1. I set each of those factors equal to 0. And I get x equals negative 2 and x equals 1. So those are actually my bounds of integration. The smaller one is my a, and the bigger one is my b. So the integral to solve this is going to go from negative 2 to 1. And now all I have to do is figure out which one is on top.
So that's when you just plug it in, right?
No, we can't plug it in until we know which one's on top. What do you mean by plug it in, actually? So we're going to go from negative 2 to 1. By looking at the graph, because I color-coded it, it's really easy to see which one of these two functions is the bigger one, because it's the one that's on top and it's the green one. But I could also just plug in a common x value to each of them and see which one gives me the biggest answer. So for example, if I plugged 0 into this function, I would get 2. But if I plugged 0 into my g function, I would get 0. Which one of those is bigger, 2 or 0? 2, so f is my bigger function. So I'm going to subtract g from f.
Oh, okay. That makes sense.
And now I can integrate.
So G can go in front. Like,
It could be g of x minus f of x, yes. I have to determine which one is bigger.
If there were more intersections,
We would have more integrals. We're going to do some examples that are like that, yeah. So let's just start with this one. So I go from negative 2 to 1 of my f function, which is 2 minus x squared, minus my g function, which is x. I simplify that. You can use your calculator if you want to. You don't have to do it the way I'm doing it. I got 9 halves for this one. Again, you don't have to do the anti-differentiation like I do, but it is a good way to check if you're not sure.
so we do intersection to find the integral.
If it doesn't give you your bounds, yes. If it does give you your bounds, then you're typically okay.
Is there any those always make me want to cry.
You never know. I did pick fairly easy ones for your homework this time. So we will definitely do two more. I think I'm gonna skip the trig one for now because I didn't put any on your homework just like that one. But it works the same way. Okay. Are we all done with this one? Does it make sense?
Yeah.
Okay, next example. Okay, so did this one give me bounds for my integral? No, which means I need to find those bounds by doing what? Setting them equal to each other and trying to find their intersection point or points. So what I'm gonna do is I'm gonna take the 3x cubed minus x squared minus 10x and set it equal to the negative x squared plus 2x. Right? Through a lot of manipulation, we can find that we intersect at -2, 0, and 2. You also could have graphed it and found your intersection points, which is typically easier, especially when you're given a polynomial like this one. Although you definitely can do it through factoring and whatnot. It'll just take a while. So this one's different because I actually found 3 intersection points. What do you think that means?
It's true line.
I'm gonna have A, B, and C as my integration bounds, which means I'm gonna have 2 different integrals. I'm gonna integrate from -2 to 0 first, and then from 0 to 2. On each of these, a different function could be on top, and chances are it will be. So I'm gonna have to test on each of those intervals. So I'm first going to integrate from -2 to 0. To find out which function is on top, I'm just gonna pick a number between -2 and 0, and I'm gonna plug it into each of those functions to see which gives me the larger value. So let's pick -1, that's an easy one. I get -3 when I plug it into G, and when I plug it into F, I get -3 minus 1 plus 10, which gives me +6. So which one of these is bigger from -2 to 0, F or G? F, because it gave me that larger value. F, I got 6.
What?
Not basically right, but we'll fix that later. So my first integral is going to be F minus G. Right, that's what I was testing to see which one was bigger. But this wasn't a 1 integral problem, this was a 2 integral problem. So now I'm going to add to this the integral from 0 to 2. And again, I have to test to see which one is on top. So I'm going to plug in +1 to each of the functions and see which one gives me the larger value. So when I do, I get G is larger because it gives me a bigger number. So my second integral is going to be G of X minus F of X. And then I can plug in the individual functions and I can integrate either on my calculator or by anti-differentiation. It is your choice.
So would you add the integrals?
Yeah, so you add your answers together.
No.
Yeah, you should be able to do integral, plug it all in, plus integral, plug it all in.
Also, I fixed the
Good. And you should get 24. Yeah, you should get 24 as the answer. Is that what you got, Corbin? Okay. Devin, you too? Yeah, awesome.
Do you want to plug it in?
It is.
Wait,
Did they do your?
I need some help.
They put it into my, they didn't follow what I did, but they put it in my.
So they gave you a specific amount, how much you're gonna pay,
That's,
which means they know where you're gonna live.
Okay.
so they haven't told you.
That's bullshit.
Enter, I would just do
I haven't
enter.
finished mine yet, so
Plus.
I don't have one yet. Because they told me it wasn't gonna matter until May, so I haven't done the email part. They send you an email afterwards or something like that, like to your parent, because I wasn't 18.
Oh, yeah.
My mom did that while I was sitting there.
Well,
Okay, can we come back to it? We have one more example.
Can I say like one more sentence?
Fast.
I didn't do that because Deanna and I both called and they told me it wasn't gonna matter until May 1st because they just put you all into an early action pool and then did it.
Okay. Did anybody have any issues with getting 24 as your answer?
Still plugging it in.
Still plugging it in? Did anybody have any major issues with understanding how we did it and why we split it like we did?
No.
No? We're gonna do one more example and it's gonna look a little bit different, but there are at least two on your homework that I made like this, so you definitely want to pay
Well,
attention.
one that has like an A, B, C, and like D.
I don't believe any of them have 3, but it is possible.
But
Yes.
It's like I just grabbed it on my calculator.
Yeah, you can do that.
Like,
Okay,
Right. Yeah.
Oh, I'm not putting 4.
so wait,
My phone is in.
she said,
I don't know if it says like it's just like. I don't know how to describe it.
okay, so this one is asking us to find the area of the region or regions enclosed by x equals y squared and x equals y plus 2. What do we already notice is different?
You have to get the Y.
Actually, we don't. So these are functions of x in regards to y. So this one is actually an area that's based off of the y-axis instead of the x-axis, but it works the exact same way. So we're gonna leave our functions in terms of y, and our integration bounds will also be in terms of y. So it works the exact same way, just be sure that both of your functions are in terms of the same variable. So it did not give me integration bounds, which means I have to find my own. And I'm gonna do that by setting my two functions equal to each other. So when I do, I get y squared equals y plus 2.
So are those our bounds?
We're getting our bounds in a second. We're trying to get them right now. I just set them equal to each other.
So they didn't put X, they just made them X's instead of F.
Yeah, kind of, pretty much. And then I get everything on one side and I will factor it. When I do, I get y minus 2 and y plus 1, which gives me my two values, y equals 2 and y equals negative 1. So the negative 1 and the 2 are actually my bounds of integration, where my smaller one is the a and my larger one is the b. You also could have graphed this, but you don't necessarily have to. So I'm gonna go from negative 1 to 2. And now all I have to do is figure out which one is larger. So which one's gonna be on top.
So you just plug in 0.
Y.
We can plug in any number between negative 1 and 2. Deanna picked 0. So this one could be my f function, and this could be my g function if you wanted to. When I plug in 0, which one's gonna be bigger, f or g?
G.
G, because when I plug in 0 here, I get 2.
Wouldn't
When
it be
I
F of Y?
Plug in 0, yes, it would be f of y. When I plug in 0 here, I get 0. It does not matter which number on the interval you pick, and it doesn't matter what names you assign to your functions. It can be A, H, W, whatever you want it to be.
You get 0.
So we're gonna get g of y minus f of y dy, which just becomes y plus 2 minus y squared dy, and I can put that into my calculator. But it's me.
You can't put Y, right? So
It's just x. It's just a variable. And you should get 4.5.
9/2.
9/2 is the same as 4.5.
What the? Got it. I actually know what's going on in this class.
Woo!
Isn't that a relief?
And then I would look at the homework and start crying. Be like, what is this? I'm gonna go home and stare at it for 4 hours.
Questions, concerns, or issues so far?
So far, no, we're done.
We are done. So there's one more example on the notes that I do highly suggest you look at it. We're not going to go over it because it's the exact same as this. It is a trig function one. But I didn't give you one on your homework that was like it, so I'd rather you focused on the homework right now. But you definitely should look at it, and it wouldn't hurt you to write it down.
So if we were to plug it in, you get the graph. Is it equal to each other?
If you're trying to get